Welcome to a brand new unit. This is lesson 79, transforming quadratic functions. Now, just because it's new doesn't mean that it's brand new. This is going to connect to some of the things we talked about in our last unit. So in this one, we're going to see how elements of the equation, how it creates shifts in our quadratic function. All right, so let's look at the first one, our CFS. We're going to describe the changes to A, H, and K, which you may remember from our vertex form equation, and being able to describe the transformations accurately, knowing whether or not it's shifting left or right, up or down, if it's flipped in and out, if it's vertical, if it's stretched or compressed. All those things will be revealed in this lesson. But first, we're going to go to decimals to just look at patterns and see what happens when we make certain shifts. The first element we're going to explore is based on A, that coefficient. So you'll remember when we talked about it in standard form, we saw y is equal to ax squared plus bx plus c. Or I only see the a there. I can't see all the other ones. If we did it in vertex form, it would be a times x, oops, made a little extra mark there, x plus h plus k. So we're going to look at that one as well. And forget the little squared symbol. All right, so let's see what happens if. And this time we're going to look at that coefficient a. Like what happens when we move this around, and we're going to look at these four equations over here. We're going to graph them. Now, the first one is going to be our base, which we know is going to be just x squared. So it's our basic one that we know is going to start here at that 0, 0. And we're going to use that as our base function. Like here's our starter point, and we're going to see what happens when we make a bigger, when we make it smaller, and when we make it negative. Okay, so base, when it's actually right as a is more than 1, when a is less than 1, and when a is negative. All right, so let's take a look at what happens with each change. So we have our base, and that's just our regular graph. So we saw that when x was greater than 1, the 5x squared, our graph was compressed. So when it's greater than 1, it's compressed. When a was less than 1, our parabola was wider. And when a was negative, it flipped. Or it was down. It was a down-shaped. Let's take a look at some more changes. I'm going to do a quick sketch and then we'll look at it on decimals. So this is going to be our base. And it just means we're going to be at that 0, 0. Because this is when there is no h at all. So there we have it. And we talked about this before. What happens when we have a positive or a negative h? And we said when there's a positive h, because these are going to be our horizontal shifts, when it's positive, we're going to shift to the left, and when it's a negative h, we're going to shift to the right, So what that's going to look like in these two examples, if I have x plus 5 squared, I'm going to move over here. So we should see that shift happening when h is positive. And when h is negative, we're going to see the opposite. We're going to see the shift happening in the other direction. So that's my sketch. Let's look at it on decimals to confirm. All right, so here are 3 graphs of h, and you can see just our regular x squared in the middle. But when it's x minus 5, we moved to the right 5. That's our green parabola. And when x was plus 5, we moved to the left 5, and that's our red parabola. So you can clearly see the difference, how it shifts when we have a positive or a negative h. All right, so we talked about the shape, if it's compressed, if it's wider, if it's moving to the left or to the right, horizontal. Now it's time to talk about vertical. And when we talk K, we're talking about the vertical shifts. We also said this when we talked about the using the vertex form to figure out the coordinates on using the equation. So we're going to do the same thing. We're going to look at the base, which would be at 0, 0, where K is equal to 0. And so we'll see those same shifts when we have a positive. When K is positive, we're going to shift up. And when K is negative, that's going to tell us how to shift down. So here in this example, if I have a positive and a negative, so I know one of them is going to have a vertex up here and one of them is going to have a vertex down here. Now, how do I tell the difference between if this is a K or an H? Big difference. So just look here. Here I already have an x squared. So x squared plus 5, whereas here I had 5 plus x and then the squared. Okay, so it was a little bit different. Here it's just connected. So if I see x squared plus 5, then I know this is K. So we're going to sketch out if K is plus 5, it's going to go up here. And if K is minus 5, it's going to go down here. So minus K plus K. Let's go onto Desmos and take a look at our graphs. All right, and there you can see it. Here are shifts from K, and it's just like we said, when we had plus K, that's our green parabola, we've shifted up, so our y is equal to 5, and when we had minus K, our parabola shifts down to -5. So our sketch is once again correct. All right, let's try one on your own. Let's talk about all the different transformations given the function f of x squared, f equals x squared. So that's our base. And now we have kx is equal to -3 parentheses x plus 1 squared minus 2. List all the transformations on k from the original function, and then talk about what the vertex of kx is in relation to the vertex of f of x. Hit pause and jot this down. Jot down your answers into your notes. All right, so let's get started. And we already know what kinds of shifts we're going to make. So let's do a reveal first, all the different things that happened. So 1, it's faced downward. How do I know? Because there's a -a and a -3. 2, it's skinny, so it is compressed. Because that coefficient A is greater than 1, or I'm going to put in actually the absolute value of A is actually greater than 1. I think that's an important distinction that we didn't make earlier in this lesson. Let's see what else we have. So we have our A, our H is a positive 1. So that means we're going to shift 1 to the left. And our K is equal to -2, so we're going to shift 2 down. So look at all the things that actually happen. It's flipped downwards, it's compressed, it's made a shift to the left and down. So there are 4 transformations that happened here. So check those off, and we're going to take a look at them in just a moment. But let's answer the bottom part first. Let's look at the vertex in relation. So f of x, we know that the vertex was going to be 0, 0. And for k of x, our vertex is -1, -2. So that's our shift, and that we've written down. Shifts left 1, shifts down 2. So let's take a look at all of this on Desmos to confirm. All right, and there we have it. Take a look. You can see all of it in real time. And it's confirmed that, yes, it is flipped downwards. We can see that our green has been flipped. Our parent function is in black. Yes, it is compressed. It is smaller than the original. Yes, it has shifted once to the left. and it has shifted down 2. So those are all the transformations that we predicted using those patterns that we were able to recognize in today's lesson. I hope you found this really helpful. Use these notes to help you, and I like looking at the pictures because it helps me see the changes that I might not be able to see in the equation. Or you could be the type of person that can look at the equation and automatically see it in your head. We're all different. We all have different talents. So that's it for today's lesson, Math Marvels. Get that practice in, get that feedback, and I will see you in the next lesson. Be well.